Hi there. Thank you for clicking on this video on the multiplication properties of exponents. Please like and subscribe to the channel if you find this video helpful. Drop a comment, question below, and check out some of the other videos and playlists on the channel. Without further ado, let's jump into what we already know. So with anything in math, you want to build off the foundation that has already been laid. Now, if you are doing this video through a course in Algebra 1, you kind of cover exponents at the beginning of the course. We introduce what they are, and then we do all things lines for a very, very long time. And so then we kind of come back into the exponents. So it's good to have a little bit of a refresher about what exponents are. Now, an exponent is a superscript that tells us how many times the base is used as a factor. So we are good on this. A superscript, if you think of super is like above, okay? So if you are super at something, you are better than everyone else, you are above, okay? Superman flies above, okay? So super is above, and script means writing. And so the word superscript means writing that is above, and it looks something like this, where you might have 5, and then you'd have this superscript, and that would be our exponent, okay? So it's writing that is above. Now, in terms of vocabulary, we have an example here. We have 3 to the 5th power, and the 3 is known as the base. Okay, it's called the base of the exponent, or the base of that expression. And then the 5 is the exponent. And what the 5 tells us is how many times the 3 is used as a factor. And so it would be something like this. It tells us that 3 is used as a factor 5 times. Now, the other vocab word in there, okay, that you might be thinking, ooh, factor, I've heard that before. Factors are things that are multiplied. And so sometimes I've defined this as the exponent tells you how many times something is multiplied by itself, until I had a student call me out on the fact that that was a bit sloppy, because they said if you've got, say, 3 to the 2nd power, they're saying the multiplication is actually only done once. There's only one multiplication. So since then, I have been much more careful about how I phrase that. So the exponent tells you how many times the base, in this case, a 3, is used as a factor. So if you see 3 to the 2nd power or 3 squared, that means 3 times 3, or you're going to see the 3 2 times. Now, when we operate with exponents, we need to know what to do with those exponents. So operating means we're adding, subtracting, multiplying, dividing. We're doing stuff with expressions that have exponents. What are we supposed to do with those exponents? Now, the way this lesson is structured, if I were doing this in my classroom with my students, I would let them explore. Okay, so I would give them the problems on the next slide. I'll click on over there. And I would let them figure out what they are supposed to do with the exponents, and I would let them handle it. So if you would like to, pause the video right now and just kind of do that on your own. Pretend that you are in a class and these problems are up on the board and you're supposed to figure some stuff out. So x to the 3rd times x to the 5th. What is that supposed to be? Go ahead and pause the video and just kind of tinker around with it for a little bit. All right, so here is what would be a great class activity, just to play with the math. We know the definition of exponent. We know that that 3 means that the x is used as a factor 3 times. And over here, we have x being used as a factor 5 times. Now, the program that I was typing in does not allow me to use a dot for multiplication. If I were doing this on the board in my classroom, I would have done it that way. But what is happening in between these two groups? So you've got this group of 3 x's and this group of 5 x's. Well, that is multiplication. So it's just another multiplication. So essentially what we've got there is x times 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 x. And so that is really x to the 8th power. So you got 3x's and then you got 5x's, and they're all being multiplied. That is the only operation that we have happening there. If you remember, the title of this lesson was multiplication properties of exponents. So we're just multiplying, lots and lots and lots of multiplying. Okay, so that was x to the 8th. Now that I've done that one, if you want to pause the video now and try the other two and just see what you get, now would be a good time to do that. Okay, so on this one, we have x squared, which is x twice there. And then we have 4 x's over here with x to the 4th. And once again, that's multiplication in between them. So we have x times x times x times x and so forth. And how many times was that multiplied? 1, 2, 3, 4, 5, 6. And so x was used as a factor 6 times. And then on the last one, we have 3 x's, and then we have 3 more x's, and again, they are being multiplied. So that is just one gigantic string of multiplication that happens to have 6 x's in it. So this is also x to the 6th. Now, when I do this in Algebra 2, I go through it about this fast. In fact, I usually just do one example because by the time you're in Algebra 2, you should have seen it before. When I have taught Algebra 1, I would give my students a couple problems to handle themselves just to see if they could figure it out on their own. Anything that you figure out on your own as opposed to a teacher just telling you what it does, you will remember that so much better. So again, it's worth it. There's going to be another slide in a little bit, and I encourage you to just pause the video and play around with this and see if you can figure out what we're supposed to do with those exponents. Now, it doesn't take too long to begin to see a pattern here. Like, okay, I'm going to have this many, then I have all these. And essentially, what are we going to conclude here? If you have x to the a power times x to the b power, and a and b just represent any old numbers, this is equal to the x to the a plus b, and what you're doing is you're adding the exponents together. So what that allows you to do is to just pretty much take a shortcut. So if you saw y to the 4th power times y to the 8th power, we don't really want to write out like y times y times y times y times y. Like, you can just kind of picture in your head, you're going to have 4 y's and then you have 8 y's, you're going to multiply them all together, and that's going to give you 12 y's, because we really don't want to do what's called the prime factorization all the time if we don't have to. It's nice to be able to do it to get the point. So you can, do that. And there was something else I was going to do on this slide, but I forget what it was. If you don't see an exponent, so if you had y to the 5th times y, you do want to remember that the exponent on that y is a 1, meaning there's just one y there. It is only used as a factor once. And so that would be y to the 6th. Okay, so that's our first rule. Now, for the second exploration, same deal as a couple slides ago. Just pause the video, see if you can figure this out. Okay, what do we do here when we're like got something with an exponent, we raise it to another exponent? All right, so on this first one, I'm going to do the prime factorization out. I might do that for the first two. So x squared raised to the 3rd power. So remember that the exponent tells you how many times something is used as a factor. In this case, the factor would be x squared. So this would be x squared times x squared times x squared. I'm going to let you think about that just for a moment. Okay, so the thing that we're cubing is the x squared, so that we're going to use the x squared 3 times. Now, this looks like what we were just doing. For this problem, I'll go ahead and do the prime factorization. Each x squared is actually 2 x's, and it's all being multiplied. So really, that is x times x times x times x times x times x, which is x to the 6th. And we're looking for some patterns here. So we had x squared raised to the 3rd power, or x to the 2nd raised to the 3rd power, and the simplified version of that was x to the 6th. Looking at the next problem, we have something being squared, and you say like to yourself, well, what is being squared? Well, x to the fourth is what's being squared. And so this would be x to the fourth times x to the fourth, which would, of course, be 4x's and then another 4x's, which would give us 8x's total. And we want to be looking for patterns, okay? So because we don't really want to have to do this out. Now, this one, we're going to get to the point real quickly. Like, I do not actually want to write all this out. This is quite a bit of writing. So I am going to use what I know. So we have x to the fifth raised to the fourth power. So this means that x to the fifth is going to be listed as a factor 4 times. And then in my head, I'm going to think, okay, so I have 5 and then 5 more and then 5 more and then 5 more. Or I'm going to go back to the rule that we just had that says if you have two things being multiplied, that would be 5 plus 5, which would be 10. And then the way multiplication works, we could just keep multiplying them in. And so we would have 20 altogether. And part of these rules is so that we are not constantly having to expand everything out. We want to know what we're supposed to do with the exponents when we're operating with expressions that have exponents in them. And so hopefully you're seeing the pattern there. So what do we conclude? If we are raising a power to a power, we will multiply the exponents. And so if I had x to the third raised to the fifth, I know that will be x to the 15th. If I have x, oh gosh, what am I doing here? X to the, I don't know, fourth raised to the 10th, that's going to be x to the 40th. And this rule will work even if you're staring at some stuff that you are like, I'm not even sure how that can be an exponent. So if you saw a 0, if you saw a negative number, if you saw a fraction, and that is stuff for much, much further on down the line in your study of exponents, but these rules would still work. And so typically what we'll do in a math class is we'll have you handle this, kind of discover these rules, and then we want to get these rules like really locked in. So what do problems of this type typically look like? Well, the directions will typically say to simplify. So you're not going to see the word solve. Okay, solve means you're looking for the value of the variable that makes it true, and there's no equal sign here. So typically the directions will say to simplify. Now, what it means to simplify, that can get a little bit dicey. This usually means to write the expression so that each factor only appears once, so that you don't have like x's or y's in multiple places in the problem. With a single exponent, I added that in with a single exponent, meaning you don't see something like this where there's like an exponent on the y here and then another exponent also applied to the y there. Like you don't want to see that. So a single exponent, and there are no negative exponents, and I put the little asterisk there. At this point, we're not talking about what negative exponents are. They can appear in Algebra 1. I usually teach them in Algebra 2 in detail because you don't usually need them in Algebra 1. But if you had negative exponents, you would need to rewrite them. So let's take a look at some of these and see how these work. So you can do these in one step a lot. So someone like me who's done these problems for a really long time, I could look at all of these and do them pretty much in my head. If you are newer to doing them, then it would be expected that you would show some work. So you might want to, for this one, do xy squared times xy squared times xy squared. And years ago, I used to say to my Algebra 2 students, when in doubt, expand it out. So if you're not sure what you're supposed to do, start stretching it out. Start like messing around with that prime factorization. Will it take you a couple extra minutes? Maybe, maybe not, but it'll definitely save you time if you get the problem right the first time you do it. Now, looking at this, I want you to remember what's called the commutative property of multiplication, which essentially means that like 3 times 5 is the same as 5 times 3. So if you saw like 2 times 3 times 5, you can actually multiply that in any order you want. So you could kind of juggle that multiplication around. Okay, and you could multiply it in any order you wanted. Now, what we have going on over here is a bunch of multiplication. That's x times y squared times x times y squared times x times y squared. So we can juggle that multiplication around, and we wouldn't typically show it, but basically what you could do is you could say, I want to juggle that multiplication around so that all of my x's were together and all of the y's together. And that would just be that commutative property, just kind of moving stuff around a little bit. Now, usually we would not do that, but like if you can see it there, it's x times x times x, which would be x to the third. And then we've got y squared times y squared times y squared, and we know we would add those exponents together to get 2, 4, 6, so it would be y to the sixth. If you blank out, you're like, I'm just not sure, go ahead and do this, like do that little expansion out. So when in doubt, expand it out. The more problems you do like this, you will get comfortable and you will find that you don't have to expand it out as much as you did at the start. But if you've never done problems like this, absolutely, like just stretch it out. It won't take you that long. Okay, for this next one, now I'm going to go ahead and expand like the first part of this out. So I'm going to do 2x to the third y squared times 2x to the third y squared. And I'm going to write that out 4 times. Okay. And now I'm not going to do this little piece of scratch work over here. I'm going to understand that that is all a bunch of multiplication. That is 2 times x to the third times y squared times 2 times x, all multiplication. Again, multiplication properties. And what I have here is 2 times 2 times 2 times 2, which is 2 to the fourth. And then I have x to the third times x to the third times x to the third times x to the third, if you need to see that. Okay, we got a bunch of x to the thirds all being multiplied. Each of those is going to be 3 x's, so we're going to end up with 12 of them total. And then I have y squared times y squared times y squared times y squared. And that would be 4 of the y squareds, which would give me y to the 8th. Now, what I want you to notice about this is that we could get there faster. Remember that the exponent on the 2 there, if you can see I'm right in the middle of the screen, is actually a 1. And that property that says we multiply the exponents, you basically multiply all the exponents. So you're doing 1 times 4, which gives you the 4, 3 times 4, which gives you the 12, and 2 times 4, which gives you the 8. Now, should you leave that as 2 to the fourth, or should you write it as a 16? That is really up to the teacher, the directions, your personal preference, like how you feel about that. Now, for this last one, I'm going to do this last one a little bit faster based off of what I just discovered here is that I've got an exponent of 1 right there on the -2. So this could be -2, and it'll be 1 times 3. So to the third power, and this will be x, and again, this is a 1 right there. So 1 times 3 is 3. And then the -2 to the third power, this is a little like, it'll come out okay here, but this is -2 to the third power, which means -2 times -2 times -2. Negative times a negative gives you a positive, and positive times a negative would give you a negative. So this will be -8 x to the third power. You do want to be careful about whether or not that's in parentheses. Now, this is a 3, and so it works out okay. We'll save that for another video. I'll probably do a little short video on it so you can check the channel, see if you can find it where we kind of get into why that matters. Okay, but that's typically what these problems look like. You can vary how much work you're doing in these problems. So you might do a lot of work, you might do a little work, you might be able to do it in one step. Whatever you do, don't internet it, okay? Make yourself think through the process. So don't trip up on what looks like distribution. Distribution is always multiplication over adding and subtracting. And by that, I mean something like this. It is something that is clearly a multiplication operation, and you are distributing the multiplication through a set of parentheses that involves adding and subtracting. If you look at this, this has this distributy look to it. So you've got that 1 exponent of 1, and so we do 1 times 2 is 2, and 1 times 2 is 2. And what it looks like you distributed the exponent to everything in the parentheses. Yep, it does. That's not what distribution is, though. So distribution is multiplication over adding and subtracting. It is true that that 2 on the outside of the parentheses actually applied to everything in there, but it actually doesn't work if you have adding or subtracting inside the parentheses. Here's why this one works. xy all squared means xy times xy, and then x times x gives you x squared, and y times y gives you y squared. But note that this one will not actually do the same thing. X plus y all squared is x plus y times x plus y, and at this point in algebra 1, we don't actually know what to do with that. Now we will figure out what to do with that. But at this point, we don't really have the tools for multiplying that. But it's definitely not x squared plus y squared, and we could show that using numbers. Okay, so if you check out the practice set, there's a problem in the practice set that will take you through that. So it has to do with the order of operations. Now, are there other rules to follow? Yes, there are several rules for dealing with exponents, but they are generally not needed for Algebra 1. You could probably figure out the subtraction rule on your own. Just if you understand what fractions are, you'd be able to figure that out. That's usually not a stretch. Now, if whatever class you're taking is requiring those rules and you'd like to see more on that, please drop a comment below. I'll either direct you to a video I have done that covers the other rules, or I will make a video for you or respond to your message to help point you where you need to go to find that information. All right, don't forget, like and subscribe for more math help. Check out the practice set on this lesson to practice these concepts, and check out the other videos and playlists on the channel, and I will see you in the next one.